Hello guys, welcome to my YouTube channel. Myself Randal Abhishek. Today we will discuss about the predictive parsing. So first LL1 grammar. Predictive parser can be constructed for a class grammar called LL1. So what is LL1? L stands for left and L another L leftmost derivation and one input symbol at each step. We will get a one input symbol at each step. So no left recursion or ambiguous grammar can be LL1. So what are the condition of LL1? Grammar G is called LL1 if and only if whenever if A tends to alpha or B beta are two distinct productions of G. The following conditions hold. A. In A, the first first of alpha and first of beta must be disjoint. This is to able to deterministically guess the production. At most of the strings, alpha or beta can be derived epsilon, since first of alpha and first of beta are disjoint. So the next condition is if A, A tends to alpha, then first of beta and follow of A must be disjoint. So these are the conditions of LL1. So the next is algorithm for construction of parsing table. Input grammar G. There will be an input given the grammar G and the output should be the parsing table M. For each production A tends to alpha, do the following things. First one is for each terminal A in first of A, add A tends to alpha to M of A alpha. If epsilon is the first of alpha, then for each terminal B in follow of A tends to alpha to M A comma B. If B is dollar, then also add A tends to alpha to M A and dollar. If there is no production in M A comma A, then set M braces A comma A to error. So we will see the example of LL1 grammar. So here is the grammar one. E tends to T E dash. E tends to plus T E dash epsilon. T tends to F T dash. T dash tends to multiplication F star F T dash and epsilon. F tends to braces E and ID. So generated parser table for the string ID plus ID star ID is here. First, the non-terminals are taken in this column, and the next, these are the input symbols like ID plus star, opening braces and closing braces, and dollar symbol. So for the first non-terminal, the first grammars are E tends to T dash and E tends to T dash in the ID and in the input symbol ID and opening braces. So for E dash, the grammar E tends to plus T dash and for the input symbol plus and E dash tends to epsilon for the closing braces and the dollar symbol respectively. For the next non-terminal T, the grammar T tends to Ft dash in the input symbol ID and the T tends to Ft dash in the input symbol opening braces. For the next non-terminal T dash, the grammar T dash tends to epsilon is in the input symbol plus and the next another grammar that is T dash tends to star Ft dash for the input symbol star and the same for the T dash tends to epsilon for the closing braces and the dollar symbol. So moving on to the next non-terminal F, the grammar F tends to ID is for the input symbol ID, and the F tends to E for the input symbol opening braces. So the string ID plus ID, one is non-arithmetic expression. The parser table for this string is generated using the productive to parser table method. The table is constructed by writing all the non-terminals rows wise and all terminals column wise. The table is constructed by writing the all non-terminals row wise and all terminal column wise. Then the table is filled by applying rules from the construction of the productive parser table. So, so the table driven productive parsing. A productive parser can be built by maintaining a stack explicitly. So it can be built by maintaining a stack. A table driven parser has an input buffer, a stack containing sequence of grammar symbols, parsing table, and output stream. It contains four. That is, the one is the input buffer, and a stack that is containing the grammar symbol, and a parsing table and output stream. The input buffer contains a string to be passed followed by the dollar symbol. Initially, the stack containing the start symbol of the grammar is on the top, followed by this dollar symbol. The parsing table is deterministically guesses the correct production to be used. So this is how the flow chart looks: table, parser, stack, and then input buffer. So we'll see the procedure of predictive parser. The current symbol of the input string is maintained by a pointer, say IP. In every step, consider the set A, alpha, where A is the symbol pointed by the IP and alpha is the top of the stack. If alpha is a non-terminal, then see the table cell M, alpha and A on the production. In that conditions, if M alpha, A is valid production, then pop the stack and push the production into the stack. If M A, alpha is error or the blank, then they report an error. So the next condition, if alpha is a terminal, then pop it from the stack and also increment the input pointer IP to the point to the next symbol in the input string. The output will be the set of production. The, the following example illustrates the top-down predictive parser using parser table string ID plus ID star ID. Grammar. So the next mentioned LL1 grammar in the previous slides. Thank you guys.